Welcome to In a Nutshell, the podcast dedicated to all things agricultural consulting. I'm Dylan Brush here with soil genius and ag consultant Bill Brush, and we're delighted to accompany you on this journey where we break down the different aspects of agricultural consulting. In each episode, we'll dive into the realm of agriculture through the eyes of Bill Brush, where consultants like Bill play a vital role in empowering farmers, agribusiness, and agricultural organizations. If you're passionate about agriculture, problem solving, and enjoy a little bit of detective work, this podcast is tailor-made for you. All right, so to start this episode off, I think we should get into talking about soil structure and the nature of soil structure. So if you wanted to kind of get into that, I feel like a lot of people would be interested in hearing what you have to say.
Well, good. Most of my remarks and a lot of my information and that I've learned over the years comes from a handful of people. Started with Dr. William Albrecht from the University of Missouri at Columbia, and one of his students that learned under him, Neil Kinsey, who founded Kinsey Ag Service, who I've gotten to know so much from him personally, and he's located in Charleston, Missouri. And then as far as the actual soil testing procedures and how nutrients are fractionated out of the soil, Bob Perry from Perry Ag Lab up in Bowling Green, Missouri. Those three people were my primary information sources. And then I read a lot from Horst Marschner and also Werner Bergman. And the good thing about all these five people that are kind of the foundation for my information that I learned was that they all came from the same place with the same idea, which gave me that idea that, if you get it right, soil will work for you. And so really the one thing I noticed about them, they started talking about something I'd never heard anybody talk about, which was soil structure. We always talked about soil tilth, or the way soil worked, or the way when you went out there with tillage tools, the way it worked up and how nice it worked or how poorly it worked and all those. But no one had really put the word soil structure together until I started listening to Neil Kinsey and a lot of the meetings that he put on that I attended. But, soil structure is that physical portion of the soil, which has to do with physics. And the other two legs are, of course, chemistry and biology. Those three foundational sciences make up how soils operate and how they really work. And so you start with, soil structure. And, soil by itself consists of, 4 parts. There's a mineral fraction, which usually makes up somewhere around 45% of that soil volume, water about 25%, air about 25%, and then organic matter or soil humus can be up to, say, around 5%. And that gives you what's in that soil as 100%. The mineral fraction, which is the part we can't really have much influence on, consists of 3 components: sand, silt, and clay. With clay being primarily the most important part of that, because it's the portion that nutrients are held on. And if you can think of a clay, of just a piece of molding clay, and taking that and just beating it down and getting it smaller and smaller and smaller, so it was just down to just a piece of clay, that would be what we call a soil colloid. And when you get down to that size, what you find is that clay has a negative attraction. It's a negative charge that applies to it. And so if you look at simple, physics, opposites attract. So it holds positively charged, ions. And when we look at positively charged ions, we call them cations. We'll talk a little bit more where the cations, how important they are later on. But right now, just understand that the clay is the only part of the soil that can actually store and hold nutrients. The sand and the silt have no holding capacity. So if you think of this simplistically and look at a very, very sandy soil that has a high percentage of sand and silt, has very little holding capacity, which means the ability to hold nutrients on those clay colloids is almost impossible. It has very, very small little area that will actually hold nutrients, which means if you're farming that, you're going to have to add a lot more nutrients to it because it has no ability to hold on to it, as opposed to a thick, gooey clay soil. It's got all kinds of clay, maybe as much as a high exchange of a 40 or a 50. Well, it has so much clay that it holds lots of nutrients. Problem is you have a hard time getting air to pass through it. So we'll talk a lot more when we get into calcium and magnesium, which are the two major components we talk about when we talk about soil structure.
Just to kind of recap what Bill was getting to in that first section, he got into who led him to understanding the importance of soil structure. Some notable names being Dr. William Albrecht, Neil Kinsey, Bob Perry, Horst Marshner, and Werner Bergman, all of which played an influential role in Bill's understanding and discovery of the importance of soil structure. Bill also addressed how soil structure really comes down to the three basic sciences, which are chemistry, physics, and biology. Bill also addresses how the clay colloid, which are the tiny, tiny little microscopic clay particles, are the only particles in soil that are able to hold on to positively charged ions, also known as cations, which is in sharp contrast to sand and silt. This information will be vitally important later on as we get more into the structure of soil itself. In this next section, Bill goes on to talk a little bit more about soil tests.
When you look at a soil test, and it's soil tests that I'm most familiar with, and it's what I use as the basis for prescribing what needs to be applied to that soil to make it better, to make it perform better, and ultimately reach its full potential, is on a soil test, the first thing you want to look at. There's a box that will be somewhere on there. It'll either say CEC, which stands for cation exchange capacity, which means the part of the soil that can hold and store cations. It'll give you a number. The higher the number, the more clay, the lower the number, the sandier it gets. Or that will also might be listed as a TEC, which is a total exchange capacity. I like the total exchange capacity because it also tells me the volume of hydrogen that's hanging on that clay particle. The organic matter, I talked about those four fractions that we can fix and can't fix. We really have little or no effect on the amount of clay you have. It's almost impossible to add clay to soil. It takes such a high volume to move the percentage or the exchange capacity up that it's not feasible and definitely not economically practical. So you're kind of stuck with what you have. If you have a light sandy soil, I always say 50 years from now, it'll still be a light sandy soil. And if you have a big, thick, heavy clay soil, 50 years from now, you're going to have still a thick, heavy clay soil. Those things don't wash out, they're there. And so we just have to learn how to manage those. The other components of water and air are really fairly simple, is that air, as soil dries out, more air moves in. As we irrigate, more air moves out, more water moves in. The perfect place we would love to be would be right where those intersect, that there's the same amount of air that is the same amount of water. And that's at the point where nutrients can flow through the soil solution, which is that mixture of air and water, to the roots and get those nutrients into the plant. As it absorbs water, it's going to absorb those nutrients in. When you have too much water and not enough air, your roots become saturated and there is no movement across that gradient because it's all wet. It needs to be drying out, getting air before those will move. If it's too dry, too much air, not enough water, it simply means that we don't have a soil solution. We just have mostly an air, and these nutrients won't travel. They'll only travel in that mixture of air and water. So that simple little concept that I just said is why pivot irrigations, micro sprinklers, drip irrigation, even sprinkler irrigation, all can enhance your ability to farm because you're allowing yourself to put on the right amount of water at the right time and allow air to get back into that soil immediately so you can start to move nutrients across that gradient and into the plant. I won't talk about it today, but one of the major things that most people miss is the role of microbiology in getting nutrients mineralized and into the plant. This is not, I want to get to the basics today of just what the soil is, but never forget that is going to be a critical stage of one of my future podcasts, we'll talk essentially the whole thing about how to enhance microbial activity and how to make them work for you.
Now Bill's going to dive deeper into the importance of clay colloids and what role they play, as well as what ions are most important to be attached to said clay colloids and in what quantities.
Think of when you look at a clay particle, you just take it down, just look at it, say maybe a little foam ball. And on that foam ball that could fit in your hand, you have 100 pins you can put into it, representing 100%. If we had the soil structure exactly right, roughly 68 of those pins of the 100 would be calcium ion. And we'd want an additional 12 of those pins to be magnesium ions. So those two cations alone would make up 80% of everything held on those soil colloids, which is by far and away the majority of what's held. But the most important to remember is calcium is about a 5.5 to 6 to 1 ratio to magnesium. And once magnesium gets higher and higher, it begins to plate and squeeze the air out and making it tougher for water to go in and air to go down into that soil. So our constant struggle to get the proper physical structure is to balance out calcium and magnesium and get them where we want to. A lot of times we don't put a lot of credibility into calcium. Most of the time as farmers we like to put on nitrogen, phosphorus, maybe potassium, maybe sulfur, but we don't always, and a lot of times it's at our neglect, we neglect to make sure we balance those calcium and magnesium ions onto that soil colloid. And as we go through future podcasts, I'll explain to you how you get more calcium onto those soil colloids and how that works. But today, we're looking at some really early on basic foundations of what we need to look at.
So you talked about how on those clay colloids, about 80% is calcium, magnesium. And so I was curious, and I'm sure a lot of other people will be as well, what's that other 20% that's held on those colloids?
Well, the first thing, like I explained a little bit earlier, the only thing that's going to be held on there, because it's negatively charged, is going to be something else that's positively charged. Well, one of the next major nutrients that's held on there is potassium. And that potassium, a very important crop nutrient, and also it needs to be held at a minimum of about 5% for most all crops. And as that is a woody crop, a tree or something that has a lot of lignin in it, needs to be up more towards 7.5%. So again, if you use my foam ball theory, you should have at least 5 of those pins as potassium, or up to 7.5 of those being potassium. The sandier the soil, even you need to have more because it doesn't have the ability to hold on to those nutrients. So we have to a lot of times exceed even 7.5 in terms of total pounds, but we're never going to be able to hold it on there. So we begin to actually feed the crop. Another thing that most people try to prohibit or at least slow down from getting on there, but is very necessary also for plant growth, is sodium. We like to keep it at 1% or 1 pin in that ball to a half a pin. We need at least some of that. There's several crops that need sodium more so. Some of the grain crops, barley and wheats, if you don't have at least a 0.5%, you'll get a portion where the seeds will blank out. So there's a Midwest is something that people would talk about take all. And what basically is you just don't fill out the seed head and you have a really poor yield. And a lot of that comes from lack of sodium. So now you're getting down to what we'll call the rest of those things held on there. One of those would be hydrogen, very, very tiny, the smallest molecule, the smallest element, I should say. And it can be held in an acid environment because the function, the reason that you talk about an acid, it means the presence of hydrogen. So if you have hydrogen on that soil colloid, you will have an acid pH. And most farmers would love to get that pH down around 6.5 because that's a point where most of all the crop nutrients are most enhanced and easiest to get into that plant. However, if you don't have a negative or an acid pH, doesn't mean you quit farming. You just don't give up. You have to find a way, and there's several ways that we'll discuss later, on how to get nutrients into the plant in a higher pH soil. Then we have things, like I say, the other cations that can be held on there. We get into the micronutrients: iron, manganese, copper, zinc. Those will basically be held in very, very small quantities in terms of how much of the rest of these nutrients are held on there. But in most soil tests, they'll say other, or they'll say other bases, and bases mean something that would have that activity to be held on the soil colloid. Then other things that we look at that are nutrients needed by the crop would be more either neutral or they'd be negatively charged, which means they would be held tightly to something else in the soil. So those would be things like carbon and oxygen, phosphorus, some very important nutrients. Sulfur is another one that would need to be. Those are all negatively charged. Chlorine, we always worry about chlorine in crops, particularly vegetable crops, but all crops need just a little bit of chlorine. We also have things like boron, which is essentially neutral, can be mobile in the soil because it's not really held onto anything, and it can move freely up and down. Then the other really micronutrients held in really small amounts are like molybdenum, cobalt, nickel, and we're even now talking quite a bit about silica as maybe another essential nutrient. And that really, when you look at all these, and if you were looking at a periodic table of elements in chemistry, you'd see calcium, magnesium, sodium, and potassium, which makes up roughly almost 90% of everything held on there. They're all together in a little square box. All four of them are held right in the same spot in that periodic table. And then if you get over to the micronutrients, you'll see over on one side they'll be all on almost in a row. And then you'll get up to your what I call your anions, which are negatively charged ions. Those are all either in their elemental state or in their compound state, like a sulfate, sulfur. Sulfur by itself is neutral, but after it gets in the soil, it becomes sulfate, and that sulfate basically is negatively charged. But those are really interesting. And one of the things I bring up now, which I didn't used to when I first started this, but I think it's really important, I think it's a really understandable trait, is that I talk about these as being essential plant nutrients. But go, if you have a chance, and look at your multivitamin. And what you'll find in that multivitamin will be, guess what? Almost all, if not all, the same nutrients I'm talking about in some form or another, or a compound that was created because the presence of that nutrient was there. And so you need exactly the same nutrients that the plants need. And if you take that one step further and you go into the soil and you get into the microbiology needs exactly the same nutrients that your plant needs, which makes perfect sense, because if it doesn't have nutrients in the soil for the microbiology, it's not going to be able to mineralize those and deliver them to the plant. So I like to think of the nutrients I was talking about as just the nutrients for life. For life to be sustained, we need all of these nutrients. And if you look at some of them, you're looking at things like combinations like hydrogen and oxygen, which is H2O, which, as everybody understands, is water. So they're all listed within these nutrients that are essential for plant growth.
So you've been talking about all of these nutrients that plants and animals and even humans need to survive. And so I'm curious, much like I'm sure a lot of people are, how do you actually get those nutrients to the plants themselves?
Yeah, one of the things you look at is that I always tell people when you're applying nutrients, it's not how much you apply, it's how much gets in to the plant. So it needs to be in a form that those plants can accept. And really, before the plants can accept them, a form that the microbiology can use them for their biological functions before they mineralize and give them on to the plants. Dr. Albrecht had a real interesting statement of always saying things like, the microbes eat at the first table. And what he's talking is they get first chance at all nutrients onto the soil, and then those soils will then be made available to the plant. We don't get them in for just applying them. They don't go immediately into that plant. But some of the nutrients that people would be most interested in are things like nitrogen, and that really has two forms of nitrogen. There's a nitrate portion and an ammonium, and the nitrate is NO3, with a negative charge to it, ammonium, which is NH4, with a positive charge. And when we get to nitrogen, and I'm going to say it's going to be at least 2 volumes or 2 podcasts to get through nitrogen. It's a very, very complex, but so important to what plants need and when they need it and what type to use become very, very important. And then you have something like phosphorus, which is a negative. It's also an anion, H2PO4, which is what the plants recognize as the available phosphorus that they want to take in. And they're usually in the soil, they're usually not held on the soil colloid, but held tightly to a calcium, magnesium ion, or something really strongly positively charged. So phosphate is very difficult to leach. Then we have the simple ones, what I call is just you have potassium ion, K+, or you have calcium ion, which is Ca double plus, or magnesium, Mg double plus, or hydrogen single plus. Those are all very, very simple to understand. They're going to go into the roots, they're going to be accepted, and the root's going to get something back off in a same charge, and we're going to be able to now have those inside. But we have all the micronutrients of manganese, iron, copper, zinc. Those are all cations, or very strong positive cations. And then we have some very simple things like carbon dioxide that the leaves actually take in and start the photosynthetic process. Then we have some things like molybdenum, which is a very weak anion. And then we have boron, which is somewhat neutral. And then, of course, we have really a strong anion, or strong negatively charged sulfate molecule, which is what plants take in when they need sulfur. So they need to be in that form, or the plant won't take them up. They won't take up an elemental S, just S with no charge. Won't go into the plant. It won't just take, a single P and go in. It needs to be in the format of basically H2PO4. Basically, it's an anion negatively charged that goes in there. And a lot of times roots will harvest that from that tied up with that calcium. We'll talk a lot more about that when we get to a phosphate podcast. The other thing that's really important is we look at all these nutrients. And I talked a lot about when we want soil structure. At the base of soil structure is those 4 cations: calcium, magnesium, potassium, and sodium. Those 4 are going to make up close to 90%. I've seen sometimes they make up as much as 95%. And sometimes there isn't hardly any room for anything else except those 4 because of the way the soil's been treated for many years.
So you talked about getting soils balanced and getting them to have the proper structure. And so I would like to ask, what are some of the things you can't change about the soil that are just constant factors that you just have to work around?
That's a great question. And I always think that I worry about things I can have an effect and can change. I don't worry much about the things I can't change. So in soils, one of the things you can't really change is your exchange capacity, or your CEC or TEC. If you have a sandy soil, 50 years from now, it's still going to be sandy soil. I can't change that. If I have a heavy clay soil, 50 years from now, I'm going to have a heavy clay soil. So that's something I can't address. I need to know how to make that work for me, and I need to know what I need to do, the different things I need for those heavy soils that I don't do for light, and those things I do for light soil that I don't need to do for those heavy soils. The other thing you can't change is your climate or your location. I grow nut crops here in the Central Valley, but I'm not a banana or pineapple grower because it's not a tropical climate. So even though I may like to grow them, I'm not going to be successful because I don't have the proper environment to grow them. You don't see, you have to grow an avocado in a place that's 100% frost-free. It can handle 0 minutes of freezing temperatures. So that's why you don't see avocado trees, except one in somebody's backyard here or there. They're grown in frost-free areas. So the climate, you can't change, There's a reason that almonds are grown in the Central Valley, because the climate is proper for it. There are some other parts of the world that also have that same climate, and we're seeing some almonds begin to grow in those parts. Another thing you can't change to some extent, and a lot of times 100% extent, is your water source. If you're back in the Midwest and you are growing your crops 100% on rainfall, you can't control when it rains and when it doesn't rain. And you can't control how much it rains and how little it rains. And so what you can't really change that, but you can change your soil structure to make it receive that rain better. But for the, actuality of the whole situation, you can't change your water source. If you have no outside, what we call surface irrigation, your irrigation's with a pump, that's your water source, and you got to learn to deal with it. If you have surface water and that's all you have, say from a reservoir or a dam or runoff, and you have a drought, you don't have control of that, do you? You don't have control of how much water you have to use or what. You don't really have a whole lot of choice in your organic material. I know there's a lot of information going out there about regenerative farming and organic farming, and about how we need to improve organic matter and all those things. And those are, in certain climates, they can be moved up and improved. But in the Central Valley here, most of our organic matter gets burned off as because of the hot temperatures, and basically oxidizes and your carbon's gone. And you can work for a while if you expose that carbon material that's been it's been tilled and you've been working on it, and all of a sudden it gets hot right after you've opened it up, there goes your organic material. A lot of people will disagree with me on this, and I'm saying you can do it, but it's a very fragile ecosystem that you have when you have super hot degrees in your soil. Temperatures may reach 140 degrees. And another thing you can't change is what other people do. So you want to make some changes and start to go in this direction. You can't change that somebody else says you're not very bright for following this guy, or this isn't a way to do your soils. You can't change that person's attitude. They're locked into what they're doing, and I always tell them, you've been plenty successful, you don't need this, so just keep doing what you're doing, and I need to change to get to what I can do better. So then, if those are things I can't change, then what can I change? Well, I can change my soil structure. I've proved it time and time again in California, across the U.S., in lots of foreign countries. Changing soil structure, getting calcium and magnesium in balance, getting the proper amounts of potassium, getting my sodium to be reduced if it's too high, or adding sodium if it needs to be bumped up a little bit. Getting our micronutrients in place is another thing that I can change. I'll explain later when we get into micronutrients how you can figure exactly how much we need to add to actually move your micronutrients up to the levels they need, and where those micronutrient levels need to be. I can improve my water penetration, not by the old standard of just adding gyp, but actually changing structure of that soil to get the calcium, magnesium back to that 6812 that I will harp about on all my podcasts. 6812 is that magic number where soil structure is in the right, proper position. And I'll explain later on another episode about where soils, if they're sandier, might need more magnesium and less calcium. But those are little pieces that are just you'll need to learn about as we go along. The other thing that I think that people don't pay enough attention is, when you change soil structure, what do you get in your soil? More air. And when more air is in that soil, and I'll explain when we get to calcium how calcium affects that air ability to flocculate and pull together to create airspace. When you create more air, you create more biology, because they're sitting there starving for air. And now that your structure's been changed, they now have the ability to do what they were intended to do, which is take your water, air balance, propagate themselves, and then deliver those nutrients to the crop. Biologically, activity will go off the chart if you can keep your air-water balance, One colony forming bacteria in a proper environment of air and water will be 1 million colonies in 24 hours. They build up rapidly. Their life cycle is real short, and they multiply rapidly. A good indicator of good biological activity that you're seeing or haven't seen, you're looking at your soil and it looks fairly, I don't want to say dead, but it doesn't look like it has a lot of activity. One of the things you'll notice when you start to build the porosity and the ability of air to get into soil is you'll see worms. You won't see the worms necessarily themselves, but you'll see the castings or where they defecate on top of the soil. And you'll see those worm castings because what they do is they're harvesting the microbiology. So they're going through your soil. And they don't go through that soil till you have enough air, because there's not enough to eat in forms of microbiology until we get air back in the soil. Another thing you can change. Like I said, you can't change what other people want to think about, but you can change your philosophy. And your philosophy is, this may be different than anything I've tried before. And I don't want to risk the whole farm on somebody telling me one episode that this is what I need to do. But continue to listen as we put these pieces together, piece by piece, and you'll find there's a lot of science and a lot of successes that have been done over the years using this philosophy and this ability to actually change soil structure, get it in the proper balance, and then supply the proper nutrients in the proper amounts for greater yields. I would suggest, as you start on your journey, think about this. This is different than anything I'm doing, so therefore let me try it on a piece of soil. Don't always take just the worst, because you'll be looking at a longer term turnover. Didn't get that way overnight. It'll take longer to get that poorest soil bed. Take something in the mid-range. Don't get your best. Don't get your worst. Something in the mid-range, because then you'll have a reasonable amount of recovery time, and you can begin to see those changes happen to you. You'll see the way the soil works, the way it feels in your hand, the way it smells, how much activity's there. All the good things that good soil health will get you over time. So today we'll call that a wrap on soil structure, and our next episode will be following shortly.
Well, thank you very much for that, Bill, sharing all of your knowledge on soil structure and giving us a little insight as to how important it truly is for having a successful crop. As you kind of alluded to, our next episode, I believe we plan on talking about water and the importance of water and good quality water, and just generally the overall effects of water on various types of crops. I would also like to say a big thank you to our listeners of today's episode. Be sure to tune in for more In a Nutshell, where we look to dive deeper into the individual parts of consulting later on in future episodes. Don't forget to like, subscribe, and leave a comment if you're listening on YouTube. This has been Dylan Brush and Bill Brush on In a Nutshell, and until next time, stay curious.